Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode. I will show you a O of 25 into n linear solution, and this is a difficult problem, really difficult problem. So I will request you to stay till the end of the video, and if there is any doubt in any portion, you just ask me in the comment section. I will definitely answer, and I am trying my best to make you understand the questions. So the question is that the maximum difference between the even and odd frequency tool. So you are given a string s and an integer k. Your task is to find the maximum differences between the frequency of two characters, frequency a minus b in substring of s. Okay. So unlike the previous problem, which has the whole string, today you only have a substring of size at least k. In that substring, the character a and b must be A must be of odd frequency and B must be of even frequency, and we need to return the maximum difference of those. Okay, so we note that substring can contain more than two distinct characters. So yeah, that's there, and we are given value k, which will help us. So if you try to see this example, you try to just see this example, example 2. This is given that k is 3. Okay, and if you select the whole window, you see the odd count minus even count is coming to be -1. But if you select only this one window, odd count minus even count is coming to be 1. Okay, which is greater than -1, and we are selecting the value is 5, the length of the window 5, which is greater than 3. So yeah, selecting something greater than k and less than n will also be optimal. This example shows it. So let's try to see the approach. We definitely cannot do an O of n square solution. The thing which is important to note here is that S consists of digits only from 0 to 4. Okay. So coming to the solution, the first thing which clicks in the mind is that the string consists of only the characters 0, 1, 2, 3, 4. So these only 5 characters they contain. Okay, and now what we need to find is that we have a string. There will be a substring, and the frequency of the odd frequency of a character. Let's say it will be x, and let's say y. There are two characters only. Let's say x will have an odd frequency and y will have that even frequency. This is how we consider. Okay, now this x and y will only consist of these numbers only. It can have only these numbers. So what we see, we pick any two of these numbers, they should be distinct, and we see that now the string consists of only x, y, or some other character, and we then process the string. What do I exactly mean by this is that I do something like for x equals to, let's say, 0 to 4, and for y equals to 0 to 4, what I do is I calculate the maximum value by taking x and y. I assume that my string now consists of only x and y. Okay, now I store in some answer variable, and I maximize the answer according to some function which will return me, which is the maximum, what is the, I mean, the x minus y count, which is the maximum value that can be obtained, right? Let's say it will have a function which will take x, y, k, and let's say some other conditions. Okay, so this is the intuition, is that we check for all the values of x and y, and I assume that x will give an odd count and y will give an even count. So that is not necessarily true. So that is why we check for all xy and yx pairs also. You can see we check for all such pairs. It goes from 0 to 4, 0 to 4, and whichever is, like, if x comma y was even odd, then yx will be odd even. So whatever will be the thing, I will calculate the maximum value considering x and y. Now how exactly do we do that? This is the thing. Now you see, we have a constraint k, right? We have a constraint of k also. So what does this mean? This constraint k, what comes to the mind is that, let's say if we have this string, we can do a sliding window approach. If we initialize this I with 0 and j with k, and this I and j are, let's say, the two pointers of the starting and end of the sliding window, we will slide this value of j as well as this value of k, depending on some conditions which I will explain. And we will also check that this value j minus I, this j minus I should be greater than equals to k. So it will always ensure that the substring has the value of j and I. Okay. So now, what do we need to return now? What do we need to return from this function? If I talk about this x and y value, the count of this x count and y count, we need to maximize this value. Isn't it true? We need to maximize this value. So to efficiently calculate this count, what I will do is that I will have some prefix array. Okay. I will have some prefix array. But now how will this prefix array? So let's say prefix array x stores all the value of x's, and we have some prefix array y. These are two arrays which store the prefixes like the count of x, right? It shows the prefix order of the count of x. If you don't know about prefix array, just search it out quickly. Because this requires a lot of computations with the prefix terms. So if you see, we are getting a sliding window, we are having some prefix array. We need to maximize this x count or y count. So within a window that is our substring, we need to maximize this within this, okay, of I and j. Now what is the x count here? If you see what is the x count in this window, it is nothing but prefix of j minus prefix of I. Okay, this is nothing but prefix of j minus I, and this I is nothing but from I minus 1. Okay, so considering the window from I minus 1 to j, that I will just take care of in the code. I'm just explaining you now. And what is y count? Y count is nothing but prefix yj minus prefix yi. Okay, this is our y count. Now, the thing is that we need to subtract this x count from y count and maximize the value. We need to maximize something like x count and y count, right? So why don't we put the value and check? Why don't we put the value? Here the a, I, j and I are of different indices, right? And they can be of any length, of any, they can be anywhere in the two ends of the string, right? So to track that efficiently, why don't we just try to see what the math would, where the math would take us? So if we put the value of x I, something like prefix I, and again we put the y value also, something like j minus this y value, right? Now it is possible to rearrange the terms. This can be written as this. I think you understood easily. And this is possible now to rearrange the terms only into i's and j's. So what do I mean by it? This value, it is possible to write it in this way. Minus. Okay. It is possible to write it in this way. Is it true? Is it true? Yeah. So what is the benefit of this? So if you just see, this will be I. Okay. What is the benefit of this? What is the benefit of this? We have, if we are in some particular index I, we can easily calculate this value and easily calculate this value. Now to maximize this whole equation, we need to maximize, right? We need to maximize this. What we can do is that we can, in order to maximize this, we should minimize this thing. This term should be minimum. Okay. For all such minimum terms, I can see for all such j, for all such values of j, I can see which is my previously minimum such term. So if I have a sliding window I to j, of I to j, I will check that what is some other sliding window, what was some other sliding window which had this prefix, this thing, this prefix of this will be y, right? This thing as I, this thing as the minimum, and we will store that in some array. Now there is a catch. Now there is a catch. Only doing this, do you think only doing this will suffice? We need to check care of the parity also, right? Which is odd and which is even. But as I told you that I am why we don't need to take care of those things, because as I already told you, I'm checking out all possible values. So if I'm taking a case of even comma odd, I will also get some odd comma even value also, right? And we are just maximizing that, so we will automatically get that. But the thing is that in the window, in this window, okay, in this window, the parity of x and y, if x is appearing an odd number of times, then y should have an even number of times, right? This should have an even number of times. So when we are, these are I and j, when we are expanding j, we will see that if there is a new y, okay, some new y has appeared, we will expand j and also the I, right? But this, what we check is that x and y, this x and y frequencies here should be different. They should be different. So for instance, we are fixing y, we are just fixing y and saying that x parity has changed. X parity has changed. From what? From what it has changed? From some other windows. As we are iterating through the windows, I will say that if the parity of x is changed, okay, this and y is fixed, then they are of different parities. Then only if they are of that different parities, then only I will store my maximum value. I will maximize the while doing this maximum value, while checking this maximum value, I will take care of that, okay? And I store this minimum in some parity thing, like what is the parity thing in which I will store this minimum? I will not store this minimum in some normal array. I will store it into a 2 cross 2 array. Why so? Because you see, parities can be like 0 1 1 0 1 1 and 0 0 also, right? Now we want to check that the first parity is changed, the second parity is fixed, okay? So so for this thing, for that particular parity only, we will be storing this into an array, and that will this will track the minimum value of this, so this whole term. We are tracking this minimum value of this whole term. So as we will code, we will also understand simultaneously. Let's check out the solution. So first of all, we have this n s dot size, okay. We need to store a prefix sum, right? How we will store that prefix sum? Let's say we have a vector of vector. So what I am doing, I am just checking a prefix, where prefix of all the characters I am storing in this way. Okay, I think you get it. Prefix of I stores the character of I. Ref I is a prefix array of I. Okay, that's all. Now how do we fill the prefix array? I have created it very nicely, but how do I fill it? It's simple. We iterate through the I, we iterate through the j. For every j, we copy the value, right? For every j, we will copy the value. So what we will write to do like what we generally do is something like prefix of I plus 1 is equal to something like prefix. If you have done the normal prefix array, something like the array, right? Array of I. We do something like this. But here there are 5 such values also, right? And only one value will be incremented in one iteration. Like at index I, there can be either 1, 2, 3, 4 or 0, right? So there only one value will be incremented. All the values will be copied, right? For only one value will be just incremented. For other all values, we just need to do prefix I plus 1 equals to prefix I. So it's nothing but what we do is prefix I plus 1 equal to prefix j. I plus 1 j. Not I plus 1 at first, it will be j. So what we do is that prefix j, we take the I plus 1 value and what we do is just we copy it, and only that value of I will be incremented, right? Only this value will be incremented, and to the next index I am incrementing, and I'm just doing the incrementation. Okay, so copied the value and just incremented it. You can do it in other way, whatever way you like. You just can do the prefix array. You should know that the prefix of I should give the prefix array of I. So that's all you need to do. So if you find something count of this thing, you increase it. So yeah, we have the prefix array now also. Let's store an answer int min, right? We need to maximize the value, so we store the answer. Now what I do is simple, is that I go through all possible values of this 0 to 5. I also go through all possible values of this 0 to 5. Okay, I go through them. Now if something is 0, if some thing is 0, let's say the count of the whole thing, if it is 0, then there is no use to take that, right? If prefix of this ith character at the end of the array is like 0, then continue. I don't need that. I just don't need that, right? And both characters should not be equal also, so we will give another check. So first of all, we also need to check that this prefix of j at n, the last value, it should, if it is 0 or uh, or what, or I is equal to j, if these two conditions hold, then there is no need to calculate anything. Okay, now answer, we can just maximize the answer. As I told you, I just need to maximize the answer by some function. I will call the function. What I will pass into the function is that let's not tell these that x, I and j. I will tell you why exactly. Let's tell these are x and y, right? Because that's how I had explained you in the intuition part also, right? I took x and y so that you just, it's easier for you to understand. These are the x and y. I just iterate to the characters x and y. I pass these x and y. I pass the k, and I also pass the prefix. Okay, this will give me the, considering string has only x and y chars, calculate a maximum difference. Calculate the maximum difference, right? And that's how we calculate the maximum difference. This function returns. This is a thing of that function, right? So and at the end we just return answer. It's quite simple. I think you easily understood this part. All I need to do is that define the helper function now. Okay, so it will return some integer, yeah, and this func will take int x. It will take also some int y. It will also take k, and definitely vector of that prefix also it will take. Okay, pass by reference. Okay, now what you have is that as I told you, we need to also store something in this 2 cross 2 matrix, right? We need to tracking the minimum value of this term. So we need to track the minimum value of the prefix I xi minus prefix xy. So for tracking min value of let's say x prefix I told you this, right? X prefix I minus x prefix y. X prefix y prefix. Yeah. So for this, I am keeping one integer track min on the basis of parities. I will also explain you like what this parity is doing. As of now, since this has the minimum value only, I will just go through this. I will just quickly go through this of the order of 2. I'll just quickly go through this and just keep track min of this ij. Set all of them to be 1e5. Okay, just setting all of them to be 1e5 because this stores the minimum value, right? We will see the minimum value of this thing. Okay, now what you need to do is initialize sliding window, right? We initialize the sliding window. It's simple. Let's say I is 0 and j would be k. That's how we initialize the sliding window. Now, and definitely it will be like it will look something like j less than n j plus plus. That's how we do, right? Yeah, this is there. Uh, Now we also need the prefix array of x and y. So xpref. So we take care of those things also. We have this prefix xpref as nothing as perfects, right? I'm keeping things as simple as possible. Also the variable naming, so that it's easier for you. Y pref is nothing but pref of y, and we also have an answer here, right? Which will calculate the maximum considering only x and y. Considering only x and y, it will calculate the minimum. So we need the calculate the maximum. So we need the minimum, right? Yeah. So we all we do is return answer. Now what will be there in this loop is the main thing of this whole problem. Now, what we need to do is that we are every iteration we are just expanding j, right? But when this y count, as I told you, when y count is some non-zero value, then I will expand the window, right? I explained you somewhere here that when y count, then with y count is just changing, I will expand the window. So if this y pref I is not equal to this y pref j, then only I will expand the left window. Now the left window, just we cannot just keep shrinking the left window, left side of the window, right? We also need to take care that this j minus I should always be greater than equal to k. Yes, this must always be greater than equal to k, and we shrink this. Okay. Now what we need to do is that we have this. We just calculated this, right? We stored this minimum with this minimum thing. Yeah. So we calculate that minimum value. So track min, that is stored nothing but track min. We also have the parity. So let's say we have x parity. So x pref of I, this is nothing but x pref of I module 2, and y parity is nothing but y pref of I module 2. So what we do after this is simple, like we just track min, we just update this track min according to the parity, right? According to the x parity and according to the y parity. We are updating this as some minimum value, updating the minimum value of some previous sliding window, as I told you. xp, this is nothing but x, so x pref of I minus y pref of I. So what I am doing here is, and we also increment I. What I am doing here is tracking the minimum value of this. As I explained you that here, this minimum value, I am just tracking it for every parities. And why I am doing this, like you might ask me that why I am doing this, why I am not showing it in a single variable, why I need to take this parity and all. That will be easily understood by this thing, that max at j. Okay, max value at j, I calculate it to something and just update the answer. Max at j, at the ending point j, what is the maximum value? So how do I get that? I just blindly write this equation, right? This x pref j minus y pref j. So x pref j minus y pref j. I just blindly write this equation and I do track min of, now comes the thing, x pref of I module 2 and y pref of j module 2. What did I do here? Now you see that again you can ask the same question, that why are we not storing it in a single variable, right? You are anyway storing the parity and let's taking the ith parity only, right? This will be I. But this is not it, right? This is not it. It's need to be of different parity. So you do a XOR 1. If it is 0, it will turn to 1. If it is 1, it will turn to 0. So if you see, what is there is that this it's told in the problem statement, the character A has an odd frequency, the character B has an even frequency. And I told you I don't need to take care of that odd and even thing, but definitely one thing I need to take care is that these things have different frequencies, right? As I told you that in this X and Y, this parity change, as I'm telling you, I am keeping Y as fixed and X as parity, then this will suffice according to our loop. According to our loop, then only this will suffice, right? So that's only what I am doing. Xpref of I module 2 XOR 1. I'm flipping the bit, I'm flipping the parity, and I'm just giving the parity of Y as same and X as different. So just to take care of that, I take the minimum value. Definitely, I do take the minimum value, but I do not just blindly take it. That is the significance of this parity array. If you did not understand, you can ask me just again. But uh, you must understand this thing. You must understand this thing, that you do take this minimum value, but you do not just blindly take it. You do check care that the parity is changed. The X and Y parity is changed, because it is told that if X has an odd count, Y must be an even count, right? To take care of this value only, we need to take that the parity of X is changed and Y is unchanged. I just take this value, all right? So yeah, that will be all. That will be all, I guess. Let's try to run it and see if it works, or there is some error. We undeclared identifier N. Okay, so I did not declare the A here. Let's it be this dot size, right? This is a function where I did not pass N also. So we are getting a wrong answer. Let's try to see what is the error. Okay, the thing which happens here is that for this max at J, I need to initialize this also J, right? These are J's. Yeah, so we do have the accepted thing. Let's try to submit it. Yeah, we have the accepted thing. Our runtime and memory is quite good. So I definitely know that this was a very difficult problem to understand. I have tried my best to give you the solution and explain you line by line of how everything is working. Still, if you are having some doubt, you can still go ahead and ask me. Like I told you, why I am using this track main and why I am just doing this XOR operation. I need to flip the value of X, keeping the value of Y to be same. That will ensure that it will have a different parity, and this loop takes care that after having the different parity also, odd comma even and even comma odd, it is just satisfied. The things are satisfied. So yeah, that's all for this problem. This was definitely a hard problem, definitely difficult to do if you have not done similar kinds of things before. So yeah, that was all. I just tried my best to understand. If you have any doubt, definitely comment the timestamp of the video. So that's all for the day. And I hope your day is going to be much easier than the problem. Thank you so much.